Hey everyone, Unit 7 is our last unit, and this is going to be about finding the local extrema of functions, aka the local min and the local max. The example problem is going to be about f of x, which is x cubed minus 5x squared plus 3x minus 1, and we want to find the local minimums and maximums, if any, that are in this function, and whether each point is a min or a max. First, we need to find the first derivative using the power rule, so f prime of x equals 3x squared minus 10x plus 3, and then to simplify things for ourselves, we can factor this out. Factoring this out gets us 3x minus 1 times x minus 3. Now we set this equal to 0. So f prime of x, the derivative of x equals 0. And when this equals 0, let's see, 3x minus 1 equals 0, 3x equals 1, x equals a third, and x minus 3 equals 0, x equals 3. So we can see that f prime of x is equal to 0 when x is a third and x is 3. What does this mean? This means that we have local minimums or maximums at x equals a third and x equals 3. How do we know whether it's a local min or a local max? We use the second derivative for that. So the second derivative of f of x using the power rule is equal to 6x minus 10. Now we can plug in a third and we can plug in 3 to figure it out. So plugging into a third would be 2. So f2 prime of a third is equal to 2 minus 10 equals negative 8. And then plugging in 3 would get us 18 minus 10, which is equal to positive 8. So because the second derivative when plugging in a third is negative, this means that when x equals a third, the function has a negative concavity, which means it is going up and then coming down. So that would be a local max. And conversely, when x is 3, that would be a local min, because the concavity would be positive, it's curving upwards. So that's our answer. Now let's begin look at Desmos to examine this further. This blue line is f of x. And we can see that at when x equals a third, we have a local max, just like we predicted. And when x equals 3, we have a local min, just like we predicted. This works because when we set the first derivative equal to 0 over here, that's when the slope of the function is 0. And when the slope of the function is 0, it's flattening out. That's when we have these points, these local minimums or maximums. So when we set this to 0, we can then double check the concavity of the function by finding the second derivative, and this tells us whether it's a local minimum or a local maximum. And that's how we solved it. Now, the next unit, Unit 8, is going to be a unit full of a review. So any tile you land on, you choose a random card from a previous unit. Thank you for playing our board game. Bye.